Welcome, everybody. I'm Chris, and I'm super excited to talk about security and why I think the traditional security is dead. I'm a CTO and co-founder at Mondu, a leader in security posture management. We help companies in healthcare, manufacturing, and financial industry to be more secure. And before Mondu, I started my career at Deutsche Telekom. We created an open source project called DevSecIO, which allowed companies to automate the security of their Linux and Windows servers. And then we created another open source project that allowed companies to quickly assess the security state of Linux and Windows servers. We founded a company and also sold this to Chef Software. The InSpec was specifically used by a lot of Fortune 500 companies and helped them to be more secure. So when we speak about security, we need to think about how has the attack vector changed, right? And in the past, hackers were mostly individuals. Nowadays, it's a crime organization. They act like a company. They have sales quotas, customer support, playbooks. Everything is super highly automated, and that means they're really focused on exploiting money from you. The other thing that happens in parallel is that due to the increase of software, we have way more vulnerabilities across everything. So that means we have a 20% increase of known vulnerabilities year over year, and we need to fix them because essentially this means the pieces of hardware that we're running somewhere, they run software and they are affected. So we have now more professional hackers, we have more vulnerabilities, and on top of this, vulnerabilities are normally exploited. Most of them are exploited after 30 days, so which gives you a time frame of 30 days for patching. But in contrast, patching takes up to 246 days in average to fix high severity vulnerabilities. So you see already, okay, more professional team, more vulnerabilities, and we have a gap in the time that it needs to exploit it versus the time to fix it. And that's not enough. Nowadays you can scan the internet within 5 minutes. And so whenever you put something on the internet, it's essentially exposed immediately because some people scan the internet all the time. So assume that once something is public, it will be detected and will be exploited. Forbes also asked a couple of independent IT and security professionals, and they figured that 80% were victims of ransomware attacks and more than 60% of them paid ransom. So we see this is a huge business. It's still increasing, and it's becoming more and more easy for attackers to essentially exploit that money. So the question then is, okay, why are we in this state in the first place? Why are we not preventing all those issues? And just want to quickly highlight why is that a problem. So assume you have two teams, and this is very simplified, but you have two teams, one the developers and operations, so your SRE team, and essentially the security team. Now, the developers, they write all their Terraform, they now say, hey, let's deploy this into prod, and then it's going to be automatically deployed. Then the security software runs, and it figures out, hey, something is not configured properly. So security team is watching all the logs, analyzing the logs, and then saying, going back to the developers and the platform engineers, hey, you should really configure this differently, otherwise it's exposing us to the internet. So the broken thing here is, first we need to deploy something in production in order to detect that it's a vulnerable thing, and then we need to work internally to fix this. So that is a long developer cycle. The other thing that happens, that most of the misconfigurations that happens are really not so elaborate. So a lot of things are known, and there are missing patches and missing or wrong configuration of your cloud, your servers, or your workstations. So let's deep dive a little bit into one specific example from the whole stack. So here you see a huge amount of like infrastructure that essentially probably you run in your infrastructure. You have some kind of desktop operating system, you probably have Git, you have local development, you have a pipeline, you have a cloud, you have Kubernetes, you have workloads, you have APIs, and so you have also like MS365 or Google Workspaces. So probably you have all of that, and everything is essentially an attack vector that can be used by teams to exploit. And we just want to focus on one specific example and why it's so complicated for us to deal with that. And just take a very, very simple example where we say, like, we want to make sure that cloud storage buckets are not public. So the security team obviously goes out and looks for AWS, Azure, GCP, and looks for, hey, is there a bucket being exposed? So sometimes it's okay, sometimes it's not okay. So they need to make those decisions based on those projects, which is great. The challenge is that the SRE team are not working in the cloud environments and the cloud dashboard. They work in Terraform, Ansible, so they automate everything. So now it's a completely different set of like primitives in their head. So that means we have two different technologies. They are interacting with each other, but it's really challenging for them to know how everything works together. So here we essentially have a flow that where we deploy a runtime, we deploy infrastructure, but there is a gap in a way how people can communicate with each other. The team that works in Terraform doesn't necessarily know how to translate the configuration from AWS into Terraform, so they need to figure that out. The security team has, in most cases, less knowledge in Terraform, so they can just give guidance, hey, in GCP you need to do it this way, and Azure you need to do it this way. So there's always some work involved in order to figure out the solution. It's not impossible, but it just takes a lot of time to digest the solution for all those problems. So of course, this comes to security therapy. The security team is always driven crazy by wrong configuration. And they're always, why is the team always generating insecure stuff? I essentially want to block them to do that going forward. But on the other hand, the platform engineers say, I don't have access to any security tool, so I don't see anything before it's being deployed. So I only get information about wrong configuration after I deployed it. So now we see already the problem. We have more professional hackers. We have an increased amount of vulnerabilities. We have a slow rollout of patches. The internet can be scanned in 5 minutes, and we essentially need to deploy vulnerable software in order to find vulnerable software so that we can fix vulnerable software. Somehow broken. And then also AI will make this problem even faster. So we will accelerate and have that problem being everywhere very, very shortly. So I think the world is not going to end though, because we can actually solve that. So instead of focusing on individual like technologies, you need to think about how can you bring the security and the platform engineering team together so that they work hand in hand and misconfiguration is not deployed into production in the first place. So focusing on our problem again, we really want to say, hey, the cloud storage buckets should not be public. And it doesn't matter which technology is involved. I really want to focus on the problem, not the technology. So you need something that allows you to express that so that you as an organization can really focusing on what do I want to configure and which way, and then you want to apply this no matter where the team is. And here I'm going to show you a simple GraphQL-based query engine that we have in our open source project, CNSpec, that allows you to verify that Terraform resources are configured properly. So that allows a team that uses Terraform to verify, hey, everything works as expected. The same can be done for AWS. And in AWS, we ask for, hey, give me all S3 buckets, and then check that those S3 buckets are being configured properly. And that allows now to implement in the same query language, you can write checks for each individual technology. Of course, you don't want to like run those in isolation. So essentially, we now have two queries that we say, hey, the bucket should not be public. We implemented this once in Terraform. And also the bucket should not be public in AWS. So we have two different implementations on the not public bucket. And then we can combine this easily in writing a policy to say there's the public bucket policy for a company. We want to check the permissions. And then we have a check that says the bucket is not public. And we say, hey, there are different variants for the check depending on the technology that is being detected. Just use the right one. And then you have the output of that. So that means you can now, with that approach, you can run one policy that you apply in every stage of your infrastructure. So no matter if you're running it in developer mode, if you run it in the build pipeline, or if you run it in the cloud, depending on what you target, you really have the same output. So that allows you as an organization to define, those are my rules, and then I implement those rules for all those technologies that I use. And that helps you to really bring the team together, agree on those rule sets, and prevent vulnerable configuration to be deployed into production and then being exposed to the internet. We have two open source projects out there that help you to implement this right now, today. Check out CN Query and CN Spec. CN Spec allows you to write those policies, checks those policies, and runs it in your pipeline. It covers a wide range of infrastructure from Kubernetes manifests, Terraform, Docker containers, Kubernetes, AWS, Azure, GCP, VMware, Windows, Linux. So all those things are covered, and you can just use the right range of GraphQL-powered engine to query all those infrastructure. Of course, you shouldn't start from scratch. So we have a lot of content available that you can just use out of the box to secure your infrastructure right now. And with that being said, we essentially just summarize. So the way we work right now, we have a professional set of hackers. We have more vulnerabilities. We have a slow rollout of patches. We have more internet quick scans available. And we, as an industry, deploy vulnerable software in order to detect that it's vulnerable. And what we do here is we essentially say this is not required anymore. We can now push the security and make security being part of the pipeline, being part of the development cycle, so that we as a team together, security and platform engineers, can build and deploy secure infrastructure. If you have any questions, feel free to reach out to me. I'm happy to help and support. Let me know. Talk to you soon.